Good morning and welcome to AP Statistics. We're going to start off today with a review of the worksheet, the 2.1a worksheet from yesterday. So real quick, in 1a, it gave you information about a distribution of 78 individuals, and the score of 62 had 33 people who scored higher than it. And then if you consider the person with 62 to be one of the 78 people, there's also 44 people that scored below that person. So the question of percentile, well, it all has to do with what percent of the population lies below a certain score. Well, again, there were 78 people, 33 above, and then plus the one guy means there's 44 below. So the percentile, the percent of the population this person outscored, was 44 over 78, which is 56.41%, or the 56.41 percentile. So far as z-score goes, the z-score of this individual would be 62 minus the mean, 56.85, over the standard deviation, 12.35, for a z-score of 0.417. So a little bit less than a half a standard deviation above the mean. It wasn't a normal distribution. You saw the shape of the distribution. So clearly it was not what you would call normal. You can know that because if the person outscored more than 56% of the population, you would think that that person would be further above center than what they were. But that's aside from the point. 1b said, what's a typical measure of center? Well, in this case, I would go with median because of the significant skew in the shape of the curve. Typical score, median, 59. On the other side, 2a, it asked you, looking at the Ogive, what would the median be? So if you look at the 50% point on the vertical axis and scroll over to the Ogive where it hits, you see it's at about a 4. That's the measure. Asked for the IQR, so to find that, you had to find the quartiles. And again, to find the first quartile, you go to the 25 percentage point on the vertical axis, go over to the Ogive to see where it hits. Turns out it's about 3.5. And the third quartile, the 75% point on the vertical axis, scroll over, it's about 4.75, give or take. I'd call the IQR 1.25. Part B asked you what the mean and standard deviation of the number of seconds of this recording would be once you factor in the 5-second gap and convert to seconds from minutes. So to find the mean, remember that what I said the other day, a constant shift, 5, does affect the mean, and so does the multiple shift. Multiplying the minutes by 60 gets you the number of seconds. So to find the new mean, it's 5 plus 60 times 4.23, which is 258.8 seconds. Standard deviation, though, is not affected by a constant increase, so that 5 doesn't affect the standard deviation at all. It's only affected by the times 60 part. So 60 times the previous deviation of 1.38 is 82.8 seconds. That's part B. Part C is more of a conceptual thing. I told you that when you have a standard normal curve and you have z-scores to denote the standard normal curve, 0 is always in the center, and we count by increments of 1 to find 1 deviation, 2 sigma, 3 sigma, -1, -2, -3 sigma. Any distribution of z-scores will have its mean at 0 and its standard deviation of 1. By converting to standard normal values, which is what z-scores are, you create a situation where the center is 0 and the deviation is 1. So that is how you answer that question. Okay, so let's talk about something new today. Well, not new, but additional, let's just say. I've attached to the Google Classroom announcement 2 pictures, which are pictures of what's called Table A in our textbook, what's typically called a Z table. In the textbook, it's very close to the back of the book. It's right after the formula sheet that you'll see on the exam, and it's the first of the tables in that section is T1, T2. And for whatever reason, page T1, table 1 isn't even marked. It's hard to find. But in any case, I've attached pictures of the z-score table. So while we talk about this, please look at it. Remember that our empirical rule, which we talked about before, is 68, 95, 99.7, which is the percent of data under a standard normal curve within 1, 2, and 3 standard deviations of the mean. Within, by the way, means plus or minus. So within 1 standard deviation is from -1 to +1. That's 68%, roughly, it's a guideline, of your standard normal curve. Between 2, so -2 to +2 is 95%. Within 3, -3 to +3 is 99.7% of your data. Again, it's a guideline, and it's also strictly just the integers. How do you find out what's at a fraction of a deviation? What's behind a z-score of 1.82? How do you do that? Well, obviously, the empirical rule is only so good as it is a guideline for the integer-based deviations. We have to have other things that help us with z-scores that are not integer-based or even beyond the 3. So we have 2 different things we can use. One is the table, which we'll talk about today. The other is the calculator, which is far more useful and far more accurate, but we have to learn how to use the table too. Okay, so what I want you to do is look at the table, and I want you to find for me, if you could, what would be the area, which is what you find in the body of the table. What will be the area that is behind, to the left of, a z-score of -2.5? So how do we do that? Well, there's 2 pages. One page is the negatives, and one page is the positives. And of course, they're going to be symmetric. -2.5. Well, on the negative page, you're going to go to where it says -2 on the left margin. It says -2 point. Across the top, you'll see what will be in the hundredths place. So you want to go to, obviously, where you'll cross-reference and come to -2.5. What do we find? Well, -2.5, 0. 0.0062. What that means is 0.62% of the distribution lies below a z-score of -2.5. Okay. Let's try an example where we're going to see if we could figure out how to use the table appropriately. Okay? Here's an example. So I'll say, what percent of students scored less than a 70 on a test if the mean is 80 and the standard deviation is 4. So let's presume there's a test that you take and the mean was 80 with a deviation of 4, and a student scored a 70. Now, 70 is not a great grade. It's not the worst grade on earth, but it's not wonderful. For this distribution, where the mean is 80, it's obviously 10 points lower than the mean. But how many standard deviations is that? Well, find the z-score. So z equals x minus mu over sigma. Now that's -10 over 4, which is -2.5. Well, that plays into our previous example. What was the area that lies under a z-score of -2.5? Well, it was 0.0062. So using the table, a z-score of -2.5 gives you area 0.0062. So what percent of students scored less than a 70? 0.62%. Not much. 62 hundredths of a percent, not even 1% of students score lower than a 2.5, or deviations below the mean. Okay, that's an example of how we're going to use it. I want you to understand that the table will only ever show you the area below the z-score you're finding. The table can't really find the area above a z-score, but there's an easy fix. Under the normal curve is 100% of your data. So if you want to find out what percent of the class scored higher than a 70, you find out what percent scored lower, and then you just subtract it from 1. It's called the complement rule. Two values that are complementary add, in this case, to 100%. So if it asks what percent of people scored above an 83, well, you find the z-score for 83, you find the area below 83 using the table, subtract from 1, and you have your answer. Okay, so in the same example, in the same vein, let's find the percent that score above an 87. So, I can't open these pens. So what percent score above 87? Why don't you pause the video, solve the problem, check it on the table, and get an answer, then play the video again to see if you were correct. Why don't you pause now? I'm hoping you paused, and now you just unfroze it to see the answer. Well, what percent of students score above an 87? The process begins with finding a z-score. So the z-score for an 87 minus an 80 over 4. Well, this time they're higher than the mean, so it's a positive z-score. 87 minus 80 is 7, and 7 over 4 is 1.75. So now you're going to go to the table, and you're going to find 1.75 by cross-referencing the left margin and the top margin. Scroll on down till you find the area. Now, it gives an area using the table of 0.9599. But again, that's the area that's below the z-score of 1.75. So what percent scored higher? Well, to find that out, I have to subtract from 1, 0.9599. And I'm going to get 0.4, what is it, 4401? 9.4, 0.0401. Okay, 0.0401 gives me the answer of who is higher than 87. So it says what percent? I'm going to say 4.01% of students will have scored higher than an 87 if it was a standard normal curve and the mean was 80 with deviation 4. Okay, what if it's going to ask instead not who scored below, not who scored above, but who scored between two values? Let's try that. Okay, so let's do between 78 and 83. So what percent of students scored between a 78 and an 83? One way to help ourselves is to just visualize the problem we're looking at. If I have my standard normal curve with a center at 80, I'm looking for people scoring between a 78 and an 83. Now that's all of this area in between. Think for a moment how we're going to use the table to get the answer of what lies between. You know the table is going to give you the area that is to the left of the z-score you're looking for. I have two values here, so what I really have are two z-scores to find. Let's find both z-scores real quick. The z-score for the 83 minus 80 over 4 is 0.75. That's the z-score for the upper score. What's the z-score for the 78? 78 minus 80 over 4 negative 0.5. Okay, so here's what you have to do. You have to use the table to find the area that falls below the scores. Now, my shaded area is right in here. So if I find, using the table, the area that's covered up to a z-score of 0.75, I will find out everything below the 83. Well, if you do that, you'll find the area that is below 0.75 is 0.7734. But the question wasn't who did that person beat. It was what percent of people scored between two values. So if you want to get rid of this white space from my answer, right now my answer is everything shaded up to here. But I don't really want this white space chunk in my answer. So if I find out the area that is up to that z-score was the negative half, I find that that's 0.3085. What if I just subtract 0.3085 from 0.7734? Well, I'll get the answer. So 0.7734 minus 0.3085 will get me my answer, which is 0.4649. So 46.49% of students scored between the 78 and an 83. Yeah, I know it's a lot of steps. Yes, of course there's an easier way. Thanks for asking. It's the calculator. But we'll figure that out next time, okay? Right now it's using the table. The reason is old people like you to suffer and struggle. So the old statisticians who had to use tables and graphs, because there was no TI 84 or 9 or whatever you're using today, well, see, they had to struggle through it, so you have to too. And they're the ones who write the AP exam. So sometimes, usually, there is a question or two or three about the use of the tables when finding answers. It's just the way it is. But hopefully, as we move forward in time, we will understand that we don't need to cling to the old ways. We could just embrace the calculator and forget having to torture the younger generation because we were tortured as kids too. Anyway, that's my own take on it. What we're using the table for, again, is to find area, which is probability, which is density, which is the percent of the population that falls under or over or between values. You could also use it in reverse. For instance, can you look in the body of the table right now? Not in the margins, but in the body of it, where all those numbers are. Can you find for me the z-score that comes closest? There's not going to be an exact one in the table, but it comes closest to the 40th percentile. Find a z-score that comes as close to the 40th percentile as you can find. So pause, try to find it, and play the video again. Do that now. Well, if you looked, you'll find that there's a couple scores that are dancing around the 0.4 zone, but the one that comes closest is 0.4013. That's the area that comes closest to the 40th percentile. Now, what was the z-score for that value? Negative 0.25. So you could find z-scores that denote certain percentiles as well if you just go backwards from the table. Find within the body of the table the number you're looking for, the percentile you're looking for, and you can back out to see what the z-score would be for that percentile. So if you're asked to find the score that is the 90th percentile, you could find the z-score for the 90th percentile and set it equal to x minus the mean over the standard deviation and solve with algebra. Well, here's the work you have to do today. It's on page 129 to 130, and it's numbers 47 to 52, and they're pretty easy and straightforward. It's just finding z, finding area. Okay? So again, page 129 to 130, numbers 47 to 52, and I'll make sure that's clear in the classroom announcement as well. Other than that, we're good to go. Have a fantastic day, and if you want to log into the Google Meet later, please do and ask questions.